solving cubic. So how do you solve quadratic? Just think about that. When we solve quadratic, we need to factorize, right? We need to factorize and then make each bracket equals to 0. Use the non-factor law to solve it. So to solve cubic or any polynomial. So if you want to solve cubic or solve any polynomial, the first thing we do is factorize. Then the first thing we do needs to be factorized, and the second thing, if we can factorize, the second thing is the non-factor theorem or non-factor law. Yeah, there's only two things we need to do. First, factorize. Well, I may change it a little bit. Maybe step 2 is factorize. Step 3 is that. Step 1 is move all terms to one side. And then equals to 0. So make everything to one side and equals to 0. Because if you want to use non-factor law, you must have right-hand side or left-hand side equals to 0. And then each bracket equals to 0. That's how you can do it. There are only three things we need to worry about. Okay, so if everything is already on one side, good, and then you need to factorize. If it's in the factorized form, then good. We use non-factor law to solve each bracket equals to 0 and then solve for x. So if we look at example 1, okay, everything is on one side, right-hand side equals to 0. We have three brackets and it's factorized. Okay, so linear times linear times linear equals to 0. It's factorized already. So all I need to say is x minus 1 equals to 0, or x plus 1 equals to 0, or x plus 3 equals to 0. So add up like any of this bracket being 0, we can make the whole equation equals to 0. So that's the non-factor law. So x equals to 1 here, x equals to -1 here, and x equals to -3 here. They are all relationship. It's either this, or that. Okay, so x equals to 1, x equals to -1, or x equals to -3. This one's easy because it's factorized part. You don't need to worry about that. So if you look at example 2, it's still in a factorized form, still one side equals to 0, and we can still use non-factor law directly. So it's either 2x plus 1 equals to 0, or x minus 3 equals to 0, or x plus a third equals to 0. Okay, so add of this bracket equals to 0. So x equals to minus a half, or x equals to 3, or x equals to minus a third. Okay. If we don't have any question for this one, now the next step for us is like how we can factorize. Yeah, how we can factorize. Okay, for example 3, you can see that we have everything on one side, right-hand side equals to 0, good to factorize now. But what we notice here is there's no constant term. Okay, if you can see this question, there's no constant term in this question. When there's no constant term, which makes the question really easy, because x is the common factor for all of these terms. You have x in every single term. Think about that. If you have constant 2, you don't have x in 2, so you can't factorize x out. But in this case, we can just get the x out. So we have x squared plus 2x minus 10 equals to 0. Okay, so to factorize cubic, we need to find one linear factor first, and then further factorize that. So now the linear factor here is x. Here is x. So I take the x out. And then we have quadratic left. Here for this quadratic, 2 and 5. Sorry, not 2. 2 and 5. So, well, we can't, like, 2 and 5 is only make a 3, so can't give a 2. So complete the square. So we need to complete the square here. We can't really easily factorize that. You can solve quadratic formula directly as well. But like I want to practice like the ability of factorizing a little bit. So what we can do is x squared plus 2x plus 9 squared half of b minus half of b squared minus 10 equals to 0. So x equals to, for those three terms, we have x plus 1 squared. Minus 1 minus 10 is minus 11. So I'll say that's minus try root 11, use a squared minus b squared form. So dot, yeah, dot. So x plus 1 plus root 11, x plus 1 minus root 11 equals to 0. What's your question? No, the square is, well, if there is a bracket here, that be 1. And if it's that, it's minus 1. I think you remember in the wrong way then. Like minus 1 squared is minus 1 times minus 1. So that's 1. Minus, and then 1 squared is minus 1 times 1. That's still minus 1. Make sense? Okay. Now we're solving that. Like, can you see that's 3 linear factors? Okay, x plus 1 plus root 11, x plus 1 minus root 11. That's 3 different factors. So what we will have is, don't forget that's 1 factor as well. So that's like 1 bracket as well. So we have x equals to 0. Or x plus 1 plus root 11 equals to 0. Or x plus 1 minus root 11 equals to 0. So we have one solution here already, that's x equals to 0. And this one we will have minus 1 minus root 11, that's one more solution. Solve that. And that's x equals to minus 1 plus root 11. Sorry? Yeah, at least one solution. Yeah, the shape you always cut the x-axis once, so always one solution. At least one, or 2 or 3. But we'll talk about number of solutions later when we talk about the sketching. But for this one, it's like when there's no constant term, I just want to say it's easy to factorize because you can just remove the x. So similar for this one, we can just remove the x. So it's x. 2x squared minus x minus 1 equals to 0. 1, 2, 1, 1. And I need a minus 1, so it's minus 1 here. So it's minus 2 plus 1 equals to minus 1. So this one will work. So it's x minus 1 to x plus 1. Yeah, to factorize that. This is to use to factorize that one. That is used to factorize the bracket, the quadratic. So what we will have is x equals to 0, or x minus 1 equals to 0, or 2x plus 1 equals to 0. That's x equals to 1, that's x equals to minus half. Okay, so 3 solutions here. Okay. Okay, these two are all right because we don't have constant term. Now look at example 5. Okay, example 5. When you look at this, what you can think about? What formula also apply? You want to try? There's my formula really matching for this one. The a cube plus b cube. There's only 2 terms. One term is the cubic term, and the other one is the constant term. Okay, there are only 2 terms. The cubic term and the constant term. And the constant term can be written as the cube form. So I can say that x cubed plus 2 cubed equals to 0. Okay, who can remember? The formula is just above. Okay, if you can see the formula is just above, I give the hint. So it's a cubed plus b cubed. Okay, so look at here, a cubed plus b cubed. So it's a plus b equals to 0. My question is, can I factorize that? How do you test yes or no? What's what I tell you? Discriminant? What's the discriminant for this question? Yeah, times 1. And what's the value? 4 minus 16. So less than 0, right? So cannot factorize. And as I tell you last time, if you remember, if you use this formula, this quadratic definitely cannot be factorized. Morning. This formula definitely cannot be factorized. Okay, remember that. So this cannot be factorized means there's no solution as well. Okay, there's no solution as well. So I can't factorize. That's it. Like we can't do anything for that. So the only solution we have is x plus 2 equals to 0 and x equals to minus 2. That's the only solution we have. Because even though you make this equals to 0, and because discriminant is less than 0, so no solution for this one. Okay, so no solution for this. Even though you want to solve that equals to 0, there's no solution for that because the discriminant is less than 0. Okay, if you use quadratic formula. So the only solution we have is this one. And the only solution we have is this one. Okay. Actually, there's another easy way to solve it. In this question, look at example 6. What's x cubed equals to? Like 1 of x cubed is 1,000. What's x cubed equals to? Yeah, 1,000. And x equals to cube root of that, right? Like because 2 to the power 3 equals to 1,000. So x is just cube root of 1,000. So don't lock it. Don't lock it. Thank you. Don't lock it. Leave it open because it might be someone else coming later. How many we have? 2, 4, 6, 8, 9. Still have 2 more. Yeah, what's the cube root of 1,000? What times what give you 1,000? What? 1,10. Yeah, 1,10 times 1,10 times 1,10 gives you 1,000. So that's the cube root of 1,000 is that. I can solve that by this method as well. You do this to factorize. It's easy, just cube root of like the other side, you get the value. Okay, so that's another way to solve it. You can solve that by using factorize as well. So what I'll do is so still make x cubed equals to 1,000, and then x cubed minus 1,000 equals to 0. So x cubed minus 1/10 to the power of 3 equals to 0. Okay, so it's a cubed minus b cubed. Okay, now I'm making the form of a cubed minus b cubed. So it's a minus b, a squared plus ab plus b squared equals to 0. Well, because I use that formula again, this one cannot be factorized. Yep, or a cubed minus b cubed. The quadratic cannot be factorized. You don't need to do anything with that because that's the formula and you can't factorize for that. So, which means there's no solution. Yeah, there's no solution for that bracket. So you only have x minus 1/10 equals to 0 and x equals to 1/10. So we have the same result. Right? Obviously, this one's easier if you can think about that. You can use this method to solve that. But if you think about factorize, if I ask you to factorize a cubed minus b cubed, you need to go for that method. All right. In some case, we will think about the method called grouping. Well, unless you can see it, otherwise you just need to normally solve cubic, like factorize cubic. But like for this one, because I tell you you can use grouping method, so I just want to revise again. What's grouping? What's grouping? Do you remember grouping? Yeah. Well, not necessarily first to last two. Sometimes you can do first one, the third one, and the second one, the fourth one. So what's the common factor for the first two? X squared. So we have x plus 4. What we have in this two? -3, so it's x plus 4 again. So yeah, x plus 4 is the common factor. What we have is x squared minus 3 equals to 0. Yeah, so x plus 4, x squared minus 3 is x plus root 3 and x minus root 3. Because we can make 3 becomes root 3 squared, and then we use the dots. Okay, a squared minus b squared. So it's x plus root 3 and x minus root 3. Okay, 3 linear factors, good enough. We solve by 9-factor law. That's the 3 things we have. Okay, this question, well, first of all, you need to see like you can use grouping, because I tell you you can use grouping, it's easy. But like if you can't see it, we need to solve by some other method, but it's still achievable. Okay, so if you can't see grouping, I can still factorize it. I'll show you how to factorize it in the next 2 questions. Maybe do one more. This one is like grouping because there's no coefficient, no actual values of a. But you can see it's so obvious that I can take 11 out for the last two and take x squared out for the first two. So I can go x squared and x minus a for this one, minus 11 and x minus a for the second two. Like group those two and group those two. So we can take x minus a out. We have x squared minus 11 equals to 0. The first two and last two, still telling you there's a grouping question, you can do that. That's x minus a, and that's x plus root 11 and x minus root 11 equals to 0. That's root 11 squared. 11 is root 11 squared, so it's a squared minus b squared. So we have x minus a equals to 0. That equals to 0, or that equals to 0. I would recommend you to write this step out. Like I know some of you can directly get the solution, say x equals to a, x equals to plus minus root 11. I know you can do that. But for some complex expressions, I think it would be a good idea to write out what equation equals to 0 and then solve it. Because you can make some silly mistakes if you just look at it and directly give answers. So the sign could be wrong if you directly give the answer. So we can just do that. All right, so all the things we talked about, I haven't used the method we learned last lesson. This is just like use the knowledge we have already to factorize all the cubics. But not all the cubics can be factorized in those methods. So let's have a look at example 9 and example 10. Well, do you think grouping will work in this question? No. Well, the first two, yes, but the second two, there's no common factors between them. So grouping doesn't work in this question. So the 11 is like it's a problem. So we need to think about to find the linear factor first. Well, there is constant. There are 4 terms. It's not like I can't easily factorize it by the method we used before. So now we need to think about a linear factor for this cubic. But before that, we need to try a value to make this whole equation equals to 0. Do you remember what's the good values to try for this question? Sorry, which term? Constant and first term, right? So first term is just 1 plus 1 minus 1. How about the last term? What's the factors? And 2, there's 2 as well, plus minus 1, plus minus 2, 3, 5, 10, and 15, and 30. Well, 10, 30, 50, I don't think I want to bother, like, at all. Like, we don't used to think about those ones, too large. So I'll start from 1 to 3 to try it. So again, introduce the box method. 1 minus 4 minus 11 and 30. Sorry? Do you mean actually try a number into the equation? Like sub a number into the equation? The thing is, like, if we get a 0 here, we don't need to do extra step. You got the solution already. But you try, but think about it, actually sub 2 into the equation. It's still very hard to do the calculation. I think synthetic is easier compared to sub a value into the equation. But yes, you can do that. Like John says, yes, but this one I think is quicker. But like depends on, you can choose whatever method you like. You can try a value, stop into the equation and see the equation equals to 0. Then use synthetic or use long division or like any other method you like. But because I like this one so much, so I only show this method in class. So which value you want to try? Do you think 1 will work in this question? Do you think sum of 1 or negative 1 will work in this question? Why not? Give me a reason. Well, think about coefficient. If you sum of 1, the value will be 1, 4, 11, and 30, right? By those 4 numbers, you can't make a 0. It doesn't matter how you add or subtract between them. Yes? When you sum x equals 1, you only get 1, 4, 11, and 30. It doesn't matter negative or positive. But you can't add or subtracting between them to get a 0. So we need to, which one works? Last term, yes, constant, constant. Well, first term in this case is plus minus 1. It will be the same as just plus minus 1. If it's not 1, then yes, first term. If not 1, yes. What value is good to try? Then pick one, 2 or minus 2? 2? Okay, let's try 2. So the first one is 1. 1 times 2 is 2. 2 plus minus 4. What's that? Negative 2. Negative 2 times 2. Negative 4. Negative 4 plus negative 11. Negative 15. Negative 15 times 2. Negative 30. Negative 30 plus 30. What's that? 0. Great. What? Genius. Good. Okay, so what you can factorize it? Like after you get this box, what you can say? X minus 2 squared. Yep. Minus 15. Good. Equals to 0. Yeah, so the 1 minus 2 and minus 15, like 1 squared minus 2x and minus 15, that's the coefficient of the quadratic term. And then the constant you try is 2, so x minus 2 must be a factor. Well, we try. It's try and error. But one of the factors of 30. So just no. As long as the first term is a monic, so it's 1, we don't need to go for the fraction thing. If it's like 2, we try integers first. If all the integers doesn't work, then we try the constant over the coefficient of the first term. Or the constant factor over further factorize that, what we can factorize for the quadratic? Minus what? Minus 5 plus 3 equals to 0. So finished. Factorize that easily. X equals to 2, or x equals to 5, or x equals to minus 3. Okay. Next one. Well, next one. I can't see a 0 on either side, so I need to first of all move the constant to the left hand side. So in this question, well, grouping might work in this question, but I'm not going to go through that way. Like, it's a bit complex. But let's think about the easiest thing. If you also try to get a factor, what value you will try? Like, what's the factors? Yeah, so what you can try? Plus minus 1 always work. Plus minus 2. But because there's a coefficient of the 2, what's the other fractional thing you can try as well? Half. Plus minus half. Okay, so that's the values worth you to try. But we'll start from integer. Okay, so the fractional thing doesn't work that well. So we start from the integer. 2 minus 5, 5 and minus 2. Well, in this case, like 2, 5, 5, 2, like can't make a 0 if you add and subtract it correctly. So I can try plus 1 or minus 1. So which one you try? 1 or negative 1? 1. Let's try 1. That's your own decision. Okay, so I try 1, like it's your own decision. So you may try 2, like doesn't matter. If it's wrong, try another one. So it's try and error. So we got 2 in the first place. Get copy the first one down. 2 times 1 is 2. 2 plus minus 5 is minus 3. Minus 3 times 1 is minus 3. Minus 3 plus 5 is always times with that. Always times with the most round number. What? Which number times to 4? The 2? No, it's always the left-hand side number. It's always that one. Yes, I do that all the time. Okay, 2 times 1 is 2. 2 plus minus 2 is 0. Yeah, so we get it right. We get a 0, so that's good. So the factor we have is x minus the value you try, so it's x minus 1. And then we have 2x squared minus 3x plus 2. Can I factorize the quadratic? Good. You now know, like, do not answer that directly. You're testing it. So why can't? Yeah, discriminant is minus 3 squared minus 4 times 2 times 2. So that's 9 minus 16. And it's actually less than 0. So you cannot factorize that. Discriminant less than 0, you cannot factorize. So you only have one solution. That's x equals to 1. Because even though you solve the quadratic equals to 0, but because the discriminant is less than 0, you won't get any solution. Discriminant less than 0 means there's no solution. So I only have one solution, which is x minus 1. So equals to 0 and x equals to 1. Okay, that's basically factorize of cubic. Choose your own way to do that. So I have shown you a lot of methods. You can try some method to factorize that one. Yes? A to D. We are not doing to the quiz today. We're doing it tomorrow. Okay, so I'll stop the recording. I will start at like 9:15, like next year. Give you some time to think about what we learned today, and next year we'll start like do some graphing, which is the easy part. So just a little bit graphing.